All right, stats. Hello. Welcome to your exam number 3, right? Exam number 3, Exam number 3, Spring 2020 review video. The second one, I'm going to go over about 6 to 8 questions here. Again, as soon as we know when we're coming back, I'll let you know when we're going to do this exam. It's probably going to be we started to do that hypothesis testing quiz, so it'll be about 5 days after you come back, whenever that is. Stats, you are in a relatively good position because I think we've learned everything. We just need to take a few exams. We've got to finish this project, which we will. It won't be too bad, so I don't want you stressing too much. Just keep up with what I do in these videos. Early next week, I'll let you know what you can highlight on your project. You're just going to put, obviously, you know the order. You're going to have your 10 best towns, 10 worst towns in terms of median family income. Then we're just going to group them who had a higher than average median family income in 2018 and who had a less. I got to look up those numbers. I'll give you more guidance on Monday. Till then, I'm just going to make some videos here with this exam review. So again, if you have not practiced these, you should practice 5 through 12 and then just come back and watch this video later. All right. Recent Gallup poll found out that info that a great deal or quite a lot of confidence in the police create a 95% confidence interval for the population proportion. P-hat time, rounded to 3 decimals, 5, 6, 7. That is the formula for a whatever percent confidence interval. Okay, so the Z star for that would be a 196. And P-hat, 1 minus P-hat, 1,082 people polled. The margin of error is 030. Add and subtract it to your sample proportion. That is it. There's nothing to state with that. Okay. A sample of 87 senior male students produces an average GPA of that with a standard deviation of that. A sample of 81 senior female students at the same school produces a GPA of that with a standard deviation of that. Create 95% confidence intervals. That means 2 separate ones for the population mean and comment on which group definitely is doing better. All right, so for the males, 95% confidence interval. Again, I'm allowed to use Z distribution here. I'm going to allow you that because the sample sizes are rather large, definitely greater than or equal to 30. So there it is. It's X bar, as you know from the previous page, plus or minus Z star times the sample standard deviation divided by the square root of n. That's my mo. This is a mean rounded to 2 decimal places. So there's the confidence interval for the gentleman, GPA. And for the females, again, type it in well. You guys know how to type things into a calculator. That won't leave you over this time away. Okay, so that is their confidence interval. Now, here's what you do. Again, you guys, if you need help with this, in the sample, the females did better. 3.34 is better than 3.19. So you want to look at the high end, what could the males possibly have as a mean GPA? And on the low end, what could the females possibly have? If there's overlap between that, the group that came up short, what can they do at the highest, at their upper bound, versus who won in the sample? What could they do at their lower bound? There's overlap there, so there's actually no clear winner. Okay. A certain factory needs to have less than, this is not a great worded question here. They need to average less than 8 major accidents in a day in order to make daily production goals. A sample of the last 90 working days found an average of that many accidents with a standard deviation of that. So obviously some days they're definitely going over 8. What's a 95% confidence interval for the true population mean, and comment on your results? All right, basically same type as the last one. Allow you to use Z there, sample size 90. Okay. Your margin of error is 0.53. Add and subtract it to, that's the formula you're using, just like the one above. Add and subtract it to 602. Okay, so the average is well under 8. Obviously, they're going to have days where it's over 8. If their average is 6.5, they're definitely going to have, for every 3, there's a 10 sort of thing. So 8 major accidents, this is definitely not happening daily. It's happening probably less than half the time, but I could word that question better. All right, let's go to the next page. We'll probably go through question 12 today. Make a lot of these videos. Again, I want you practicing the ones I don't give answers on. Practice them for the next day, so forth. I do have extra copies of this in the high school office. I don't know if you guys are allowed to get in there. I called the high school today and nobody picked up, so I forgot to listen in there. Anyway, hopefully you got stuff yesterday. Willie Bob Deckham got 284 hits in his first 957 major league at-bats, created a 95% confidence interval for his population portion. What can I expect him to kind of do in the future there? Can use this to predict what he would do next season. Anyway, P-hat, plus or minus C-star. Time he scored of P-hat, 1 minus P-hat, over the sample size. Margin of error, 0.29. Anyway, between a 268, 326 hitter, he could become. So he could do worse, he could do better this season. 132 sampled male students in a certain college of science had an average ACT score of that with a standard deviation of that. 103 sampled female students in the same college of science had an average ACT of that with a standard deviation of that. Create 95% confidence intervals, 2 separate ones, for the population mean and comment on which group performed better. Letter Z here, 196, 2.9 over root 132. The males had a margin of error of 0.49. So again, the males in the sample did win, so you have to look at their lower end, okay? The females, 196, 3.1 divided by the square root of 103 at a margin of error of 0.6. So add and subtract it to their sample mean. On the high end, they could have a true ACT score. That, as you can tell, Yogi's in the area and he's watching the front door like a hawk, so he might bark. And there'll be no editing here, so I will try not to swear at Yogi over a video here. Anyway, the males, the lowest their true mean could be is 28.81, we would think. The highest we could expect that is 28.80. There is not overlap, just barely. So no overlap means the male ACT scores are statistically higher. All right, you want to find the sample size needed to produce a margin of error within 1. That is the formula. Z star times standard deviation divided by the margin of error you desire. 95% confidence interval, 196, times 8.5 divided by 1. You square that. Get that decimal, you always round up. You always round up. So 278. This time, 90% confidence interval. Z star is 164. Standard deviation, margin of error. Even if it's 0.4, you round up to 783. All right, here's the last page. Boxes of a certain brand of cereal claim to be 16 ounces, but a rep for a consumer advocacy group wishes to see if there's evidence that the mean net weight is less than. That's what we're going to use. Less than. The mean is less than 16. So for the null hypothesis, you could say greater than or equal to 16. That's fine. That is the opposite of that. Or, you know, a lot of places always use equal because you're just going to say there's statistically speaking, there's no difference from 16. Either or, but you can use greater than or equal to if you want. You sample 110 boxes, you weigh them, you find a sample mean that is less than 16. That's the standard deviation. Is it, statistically speaking, that far under 16 for them to be lying? All right, appropriate test of the hypothesis at 5% level. It's a left-tailed test. Left-tailed, alpha is 0.05. That's a negative 1.645 z-score that begins the rejection region. That is the formula we're using for my test statistic. There it is. Negative 4.32, solidly in the rejection region. I reject the null hypothesis, and I do say that the mean is less than 16. Now, some of you could also think about this, you know, if they're lying in either direction, it's bad. So some might have, you know, they claim that it is 16, so you would say it's not 16. In fact, a two-tailed test would be a little bit stronger here because notice the rejection region, you'd have to have a bigger z-score to reject its, you know, bigger absolute value-wise, that is, than you would here. Okay, so some folks might have that. Either way, you're rejecting the null hypothesis no matter what. Last one for this video. A factory claims to have no more than 5 work stoppages on their assembly line each day. The CEO of the company has a data analyst check this claim in a sample of 90 days, finds more than that on average, with a standard deviation of 1.36. Tests their claim at alpha is 0.01. No more than means less than or equal to 5. You're going to do a right tail test, and that makes sense because the sample mean was bigger than 5. Right tail test, alpha is 0.01, that is 233, that begins the rejection region. Test statistic time, I'll let you use Z because the sample size is 90. In an upcoming video, we'll have to get out that T table. All right, so your test stat is 3.70. It's in the rejection region. We reject the null hypothesis and say that the mean is greater than 5. All right, folks, you got about half the answers for this test review. Work on the next part, all right? And I'll give you about 6 or 8 answers in the next video. This is Yak Math Videos, signing out.